Dynasty arranged this webinar to show some concept associated to the roughness evaluation, including roughness definition, equipment used for profiling, and data elaboration. So it's a general overview and presentation of tools and equipment. So thanks all to join us. So a small presentation of myself. I'm Umberto Pinori. I am a senior payment engineer at Dynasty with more than 15 years experience in payment survey and evaluation. I'm responsible for equipment and software application, R&D activity, and lead of the consulting unit. So you can see here my contact or social media. So please feel free to contact me and ask any question regarding the webinar. Before I start, some information about the webinar. So the webinar will be recorded. The camera is always off for all the attenders, and the attenders, if they want, can sign as anonymous. The attenders can switch on the subtitle themselves from options panel. Otherwise, subtitle is off. And for any question, since any attenders is always on mute during the webinar, please use the chat to write your question. We have a small space at the end of the webinar to collect all your questions and provide the relative answers. So we can start with an outlook. Today we speak about roughness concepts. So it's important to know what is the roughness and what we are going to measure. Equipment for profile and measurements, which are the main parameter associated to the roughness and in general to the surface characteristics of the road. And a presentation of the Dynasty Explorer software, that is our software for profiling data elaboration. And as just said, a small Q&A section. So maybe some of you or most of you are already familiar with roughness, but to introduce to anyone that is not familiar with, roughness is, and in particular the pavement roughness, road roughness is in general defined as an expression of irregularities in the pavement surface that worsen affect the ride quality of a vehicle. So it's important that we define what means roughness and what means irregularity that affect the ride quality. If you see this picture on the left, you have a road, a rough road, and on the right picture, again, you have a road, but is maybe they have a big bump by hills, but is not a rough road. So we'll see during the training what means this different. And we need to start from a roughness definition just to clearly identify what we are going to measure. The road roughness is a condition used to measure deviations from the intended longitudinal profile of a road surface with characteristic dimension that affect vehicle dynamics, ride quality, and dynamic pavement loading. So we need to be sure that the dimension of, I say bump, but it could be unevenness, and this dimension that usually is measured in terms of wavelength affect the ride quality of the road or pavement in general. So which are the roughness effects? There are different effects that come from a rough road. It is important to know which is the issue that are generated by the rough road. Can be by the time or during construction. The first one is the vehicle dynamic. So usually we have an increasing of vibration, and these factors generate a reduce of the road quality. So we have a bad feeling of the driver and the passengers that are inside the vehicle during the drive on a rough road. And sometimes the vehicle dynamics, so the vibration are so high that the driver can lose the control or have a problem to control the car during the drive. Another point is the dynamic load. This means that since the car or the truck is going to bump, of course, they have a raise phase and then they have a fall phase. And when they fall, they increase the load in the pavement. This means that you increase the stress applied on the road, and by the time this can affect in a reducing of the pavement life. Another important point is the drainage, because of course, the roughness can reach a level where there is a misconfiguration of the road platform, and this fact sometimes create problem to the water cannot be properly addressed on the edge of the road. So the accumulation of the road on the pavement generates quickly the aquaplaning problem, and this is is increase the danger for the car on the road. The last 2 points, of course, is the vehicle maintenance, because increasing the vibration, you increase the parts consumptions. And of course, again, we have a fuel consumption, so that we have to pay much more money and we have more pollution in the air. So, which is the dimension of the roughness? As we seen in the first slide where we talked about irregularities that affect the ride quality. So we need to measure that type of irregularities. So we need to define which is the dimension of that irregularities. So very often that irregularities are called unevenness. Unevenness is a concept associated to the roughness. This unevenness is a deformation of the road from the true planar that, of course, can affect the car. And usually the wavelength is bigger than 0.5 meter. So the unevenness is in a range between 0.5 meter and maybe 40 meter. But of course, on the road, there are other irregularities. But the dimension of these irregularities is much, much lower. And one can affect what we call megatexture. So is a dimension of wavelength that is from 0.5 meter to 50 millimeter. And this type of irregularities usually affect just only the tire deformation. And then if we go inside the pavement and we zoom in again, we find other type of irregularities, that is the irregularities between the grains of on the surface. And this difference in height usually affect the macrotexture. Macrotexture is responsible for friction in wet condition. So it's very important. And we see later that we can measure this type of irregularities. And we can define the macrotexture using the profile laser. So macrotexture is characterized by wavelengths that are included between 50 millimeter and 0.5 millimeter. And again, each single grain has small irregularities on the surface. And these small irregularities is what we call microtexture. So microtexture and macrotexture. So this is microtexture. And the microtexture, of course, is responsible for the friction in dry condition. And microtexture has a wavelength below 0.5 millimeter. And microtexture cannot measure by the ordinary profile laser. So after we defined what is the irregularities and what is the unevenness, and I want to give you an example of flat road, or what is in our idea a flat road. You see two pavement two roads that are different from geographic characteristic. One is in a flat land area, and one is in the hill. So there is a sequence of bump and sag. But from a roughness point of view, both roads are quite flat because the wavelength of this ondulation is so big that not affect the road roughness. So both the profile, the longitudinal profile of both roads will generate really small deviations. Here, an example of rough road, that is the opposite side. Both of these roads are in a quite flat land area, but you see that the road surface has a lot of deviation from the true planar. So, and this ondulation here, this unevenness, the wavelength is like 2 or 3 meters. So this small bump will affect a lot the roughness. And the driver and passenger will have a lot of bump inside the car. So the road roughness will affect a lot the passenger and driver comfort. So exactly, this is what we want to measure and what the equipment can measure. So in terms of measurements, so which is the proper equipment to measure the roughness of the road? Of course, the traditional one, the old one method is defined by the ASTM standard E1364, measuring road roughness by static level method. So this is traditional topographic survey. We use a road and level, and in some way also the inclinometer can be included in this type of measurements. Which type of profile we get is a reference profile. So it means that you can measure the height of each point. So you have a true measurements of the Z axis. The negative point is the speed of the measure because it's very slow, because we need an operator that walk on the road and measure point by point. And since the sampling interval cannot be greater than 25 centimeter, it's very hard to measure kilometer 20 centimeter by 20 centimeter. So we can use another standard reference. Is the ASTM E950 is measuring the longitudinal profile of traveled surface with an accelerometer established inertial profiling reference. So you see here, there is an example of a profile. You see the red dots that are the laser, and there is accelerometer inside. So, and we can collect a inertia. We can collect a relative profile. So the profile is relative because, of course, we cannot measure the wavelength that is like over 100 meters. So we cannot generate the profile of a mountain, for example, but the speed, but we collect only the wavelength that is useful to measure the roughness. And the speed of measure is very fast. Here we have a video that demonstrates that the RSP can work in city area or in the highway. The RSP speed operation is from 0 up to 120 kilometers per hour. Dynasty developed a system called stop and go. So the profile can be collected also at 0 kilometers per hour in the city. If you stop for like a red traffic light, the profile is perfectly generated anyway. So the operational range is 0, 120 kilometers per hour. Which are the components inside the inertial profiler? We have a laser for elevation detection, so to measure the distance between the RSP bar and the ground. We have the accelerometer that compensates the movement of the car. And then we have a distance measurement instrument, DMI odometer, that collect the distance in very accurate way. And then we have additional components like the raw camera. So we can take pictures of the surrounding area. So in post-processing, engineers can have an idea of which type of the road is going to elaborate. And GPS antenna, of course, to have a geolocalization of any information. And in this case here, there is a picture of our electronic processing unit that collect all the information. Dynasty has two types of RSP. RSP stands for Road Surface Profiler. One is called Mark III. It's a front beam designed to be installed only in front and hold up to 21 lasers. So you see here how many red points there is on the pavement. And more points we have, and more detailed we can detect the cross section. So we see later what is the cross section. The RSP Mark IV is the second type of profiler we produced. Is a portable laser. We can install one or two lasers only. The installation could be done in front or in the rear part. For the rear part, we have a special lock to fix the RSP on the towing vehicle. And the lateral position can be adjusted to be sure to collect the data in the wheel track. Just an idea of which are the reference standard requirements for a class 1 inertial profiler is very important that profile sampling interval maximum is 25 millimeter and the vertical resolution is 0.1 millimeter. So these are the two main characteristics of a class 1 inertial profiler. Here is a dashboard of the operator. So what see the operator during the collection time. Here is the fixed picture, and here we have a live on acquisition. We can see the MPD, so the mean profile depth information. We can control the signal from the lasers. We can see a cross profile. We can control of the station speed, IRI, that is the International Roughness Index, that is the most common use parameters for roughness, is automatically calculated on live. And we can have GPS information, IMS information, and the raw camera. So we talk a lot about longitudinal profile, but what is a longitudinal profile? So here you have an example that comes from a Mark III. You see three colors, because one is for left, one is for center, and one is for right wheel path. As you can see, the profile report only the elevation measured from the laser and nothing else. So it's not easy or quite impossible evaluate the roughness just based on the profile. Of course, looking at this graph, you can identify a first section where the roughness is for sure lower than not the last section, because in the profile there is a lot of peaks, but you cannot quantify the roughness from just the longitudinal profile. So we need an additional elaboration to calculate roughness parameter and evaluate the roughness level. Here is a graph that reports a comparison of a profile collected by inertial profiler like RSP and the static device like inclinometer. So if you see both systems collect very similar, very similar profile. This means the inertial profile can, since the inclinometer or the static device is recognized to be the collected the through profile. In this case, we can say the inertial profile are going to collect the through profile for the roughness purpose. And here you can see that what we see, how we can pass from the longitudinal profile, for example, to the International Roughness Index. So here you cannot evaluate or judge the roughness, but here you can apply a judge if you define the thresholds. Of course, you can see that where there are peaks, positive or negative, of course, there is a reflection in the IRI, because IRI sum the variation of elevation, both positive or negative. So where is more variation in the profile, of course, you have higher variation also in the IRI. And the last part is very significant for this. Associated to the longitudinal profile, of course, we can have the transversal profile evaluation. So if you link all the elevation detected from the laser transversally, you can recreate the transversal profile. And the most typical use for the transversal profile is to evaluate the presence of rutting. Rutting is important because during drain, there could be an accumulation of water that increase the risk of hydroplaning. So we need to standardize, there is a standardization of the road roughness evaluation. So by the time several parameters have been developed, the most common one is the IRI. IRI is based on the quarter car model algorithm that simulate a car that drive at 80 kilometers per hour. And there is a simulation of the car mass, a spring and bumper, and a mass that is come from the wheel. Of course, this model reflect all the elevation get during the profile. So you can see here a video where there is shown that here IRI is increased and anytime there is a variation in the pavement profile, both in positive and negative direction. Also, there are other very important parameters over the IRI. Maybe any national road authority developed their own parameter, but IRI is the most common one, together with a straight edge method, so that simulate a straight edge on the pavement and measure the difference of height. And most of them can be calculated by Dynasty Explorer software. In order to provide you an idea of which is the dimension of the IRI, here you can see a picture that comes from the Little Book of Profiling. That is the most common one, book that describe the profiling. And here, for any different type of road or pavement, there is an interval of reference level of IRI. So 1.8 is now one of the most used value as threshold for acceptance of new work. Here there are some reference from Italian Road Authority and Highway Agency. So 1.8, and there is a limit of acceptance that is 3.5. So between 1.8 and 3.5 is applied some penalty. Over 3.5 is an acceptable level, and reconstruction is mandatory. But of course, I'm pretty sure that any country has its own technical specification. Here, just to mention that there is not only the case of road roughness, but the roughness is evaluated also in airport case. So airport is a different situation, of course, but since the aircraft drive very fast, the risk increase. So FAA in 2015 released the AC 150-5389, the guideline and procedures for measuring airfield pavement roughness. And the parameter used to evaluate the airport roughness is the Boeing bump index. So Boeing bump index is basically a straight edge calculation, but which is the characteristic that the wavelength taken into account is much longer. If you think at the car, the distance between two car axes are around 3 meters, 2.5, 3 meters, and the distance and the wavelength that affect the car quality ride is around 30, 40 meters for IRI parameter. But in the airport case, the distance between nose gear and the landing gear is much wider, is 20 meters. And the wavelength that affect the aircraft dynamic can reach also 120 meters. So the wavelength is much wider. So the parameters are a little bit different. In Dynasty Explorer, we have quite complete implementation of Boeing bump index calculation. So the BBI can be automatically calculated by our software. Here is reported the picture that is the acceptance criteria. The BBI has to be always below 1, independently from any wavelength mostly affect each single point of the pavement. So it's quite easy to be interpreted. Talking about rutting evaluation, historically, the rutting evaluation has been measured by a straight edge and a ruler meter. So the reference could be the ASTM E1703, measuring rut depth of pavement surface using a straight edge. And of course, you can see here that you have a straight edge, and then you can use a cone or a ruler to measure the rut depth. That is the D distance specified in this picture here. Today, there is interested also sometimes to measure also the water and treatment here, so the water accumulation that of course need to take into account the slope of the pavement. With the inertial profile, we can do something similar. Of course, if you link point by point, detected from each single, the elevation detected from each single laser, you can recreate the transversal profile of the road. And if the software generate a virtual straight edge, you can measure the maximum depth of the rutting. And this is what reported in our software. So more laser is included in the bar and more accurate you can estimate the cross section of the road. As we see in the introduction, the other important parameter for the road surface, in this case, that is not linked to the road roughness is the macro texture. So macro texture and road roughness stay in two different sectors. And this because the wavelength that affect the road roughness is quite completely different from the wavelength that affect the macro texture. So traditionally, the reference standard is the ASTM E1845, calculating pavement macro texture mean profile depth. As the sand patch method allow to evaluate the macro texture in terms of estimated texture depth. So the criteria was use a known volume of a specific type of sand, and then the operators start to spray the sand over the pavement in a circle way up to the moment the grains come out from the sand. So they measure the diameter of this circle, and using the equation of volume divides the area of the sand, you can measure the height. So the height of sand is a parameter used to measure the macro texture. Of course, this procedure is very long because it takes time, and you need to close the road, and operators spend time with risk on the road. So the technology allows us to measure the macro texture using lasers. So the standard as reference could be the ISO, also the previous one, and this one is the ISO 13473 one. And of course, what's changed? Changed that from a typical road profile laser, we need to increase the vertical resolution, that from 0.1 now it's 0.05. We need to be more and more accurate. And the horizontal resolution is not greater than 1 millimeter. So we need to recreate the profile grain between two grains and not just over the pavement. The mean profile depth is not the same of the estimated texture depth, but the standard report an equation that allow to correlate ATD to the MPD, and this is the equation. So in this way, we can measure the macro texture in both way, and we have a thermal reference. So now we can go and see which is our software. So this is the panel of Dynasty Explorer. Dynasty Explorer work based on the database. So we can generate a new database. So we create a folder, and we can change the name to the folder if you want. Demo profile. Profile collected during webinar. So you can add more description also. And you can close this one. So now we are going to import the profile data. So we have the option of import, and the system goes to import a long series of files. The most common one for profiling is the .rsp, .erd, and .pro, that is the Texas profilometer. So both three formats are codified and can be imported from different devices. Okay, so here you can have some option during the import. You can specify if you want to provide some average of the data. In our case, we don't need to pre-filter or pre-average the data, and we can import. So here, this is the icon of the laser, and here we can see that we have a long series of parameters that we can see. So all the lists here are included. The data can be shown or visualized in a graph. So you see here that in this case, I select a profile have been collected in city area. So the speed sometimes drop to 0. but the profile is still valid in any case. There is some visualization option that allow to zoom in, and this can be particularly useful for IRI or for parameters data. And we can adjust the limit of any axis. Very important is event in the image. The driver or the operator can record events. So there are some preset letter associated to the effects of the road or event. And if you see here, now I'm going to zoom in, we have collected the surrounding area every 5 meters. So the system collects automatically every 5 meters the surrounding area characteristics. And you can also report parameters on the picture if you want, when you want to save or export the picture. And very important, you can also generate a video. So if you want to merge all together the picture in order to have a video, you can do that. So through this command here, the system generate the video of all the picture together. Now it takes a little bit time, and we can put there. So IRI. Here you can see the data, IRI data. We can select here, and you can see that the data is every 10 meters. So IRI has been collected during the collection phase at 10-meter sampling interval. Usually the sampling interval report is different. So in this case, you can apply an averaging. So you go here and you say that you want report the data every 100 meters, for example. That is 0.1 kilometer. Okay, so, and you see that now you can better, it's like a little bit smoother and you can better interpret the data. So I change here. And you can see that the last part is much more rough than not the rest of the road. That is, an existing road is not highway, so the level of 3 is not bad for most of the road. And this is the longitudinal profile that we've seen before. And of course, it's reflected in this IRI. If I go, I can also see the view table. So all the data that is reported here in the graph can be also visualized in the table format. So, and for the table format, you have the left wheel path, the center line, and the right wheel path of the lane. There is a value that is the average between left and right, and is reported also the maximum that can be useful to judge the critical point, the critical factor of the road. At the same way, also ride number. Ride number is another typical roughness parameter that is used to evaluate the roughness, very common use. And now we can see all the rest. We can see that we have the mean profile depth. So the texture, you can see here that the axis comes from 0 to 1.8. So the roughness, the macro texture level is detected point by point. And also in this case, we can apply a filter of 10 meters. So the macro texture is quite high, is over 1.5, but is a country that the data is collected in North European country where they have a big macro texture surface road. And then the last one, that is the Rutting. Rutting has some peaks that sometimes don't allow to have a very good visualization, so we need to perform an averaging. And in this case, you can see that is better. So, and you can cut, and you can see also here there are some Rutting. So sometimes it is not easy judge just only parameter. So if you want to combine more information, you can go here and say set up plot, and you can decide which is the parameter you want to consider at the same time. So, and the most information are overlapped. And if you see here in this area, Rutting is high, and also IRI is high compared to the rest of the pavement. So maybe I want to go here and see what happened. So you can go here and you see that in this case, there is a big difference because this is a very rural road. And of course here, the Rutting is just maybe come from puddles on the road. Is not really a rut value, but it is more a puddle or missing asphalt that generate that type of rut. And of course, it's a rough road, so there is a lot of bump. Also, if you see the camera during the movement, there is a lot of bump, and this affect, of course, the rough value. So here, just to show you how it's the software provide you tools for an easy interpretation of the results. And the last point that is missing, we have graph, we have table. Of course, the table can be easily exported in Excel, and I can select which are the parameters I want to export. I want, for example, Rutting, MPD, and IRI, and I can apply also an average. And here is the file generated. So you can see here the IRI, and that is the average. IRI is averaged 100 meter, and mean profile depth, the MPD is reported with sampling of 10 meter, and Rutting with the same sampling, with the left, center, right, and the maximum level inside the interval, because Rutting is collected every meter. So here is reported the average of the 10 detection measurements, and here the maximum one. And now what is missing just to have a graph, a geospatial interpretation of the data. So if we go here, we have the option view in DTMap. So this is the Dynasty map model. And you see that immediately you have a plot. So you can go here, you select which file you want. In this case, we have just only one file. Then you can select which is the parameter you want to evaluate. In this case, IRI could be fine. Then you can set the thresholds you want. So we can fix up to 8 thresholds. And in our case, maybe we want just 2, or maybe 3 is fine. So we decide that this below 2.5 is green, and below 4 is yellow, and over 4 is red. Then you can decide if you want to evaluate that color based on the average of the tree value, or the maximum, or the minimum. as you prefer. And then you have the last one where you can have some option to decide if you want to plot points or lines and the dimension of each element. So now we can go refresh map, feed zoom, and you see that the GPS track is reported and any 10-meter interval is colored associated to the criteria we decide in this panel. So this is important because you can immediately understand where you have problem or not. But since it's not easy to share the information you have inside Dynasty map model, there is a way to export this information. So we can export a map, just says open, and the data are opened in Google Earth. And here you can have a better visualization of the data. And when you click on a single element, you find the demo profile, the title of the property, the name of the alignment, and the date of the survey, the change interval, and the IRI value. So in this case, it's red because it's 7.35 meter per kilometer. So you can easily judge the survey, and you can save, just save location with name, and you can have demo IRI data. And you can save, so you can send this data to your client and share the information in an easy way. So, and everything can manage from the software in a quick steps. Here we can go in hide, and we can close. So now we are going to summarize the what we've seen in this today webinar. So we saw what is the road profile and how we define the road profile and the road roughness. And more important, which is the relationship between pavement profile and the roughness. So roughness is affected from some characteristic of the pavement, but not all the shape of the pavement affect the roughness. And this is due to the wavelength and the parameter wavelength affected. Then we have, of course, we have seen the equipment needed to collect pavement profile, and in particular the potentiality and the benefits to use the inertial profiler system. The main parameters for road roughness evaluation, and of course IRI in road case and BBI for the airport case are the most common use. We have seen the Dynasty Explorer software and all the tools associated for the export of the information, the report creation, and the geospatial representation of the data that are very important. So you can share the information and you can have an easily and quickly evaluation. So that's all. Thanks all for your attention. And please add your question in the chat so I can go read and answer to any question. Thanks to all. So Javier asked, which is the criteria for the wavelength filter? So if you calculate, it depends on which parameter you want to calculate. IRI, for example, the IRI is the algorithm inside that takes in consideration only a certain amount of wavelength. So it's not the operator or engineers that has to specify which type of wavelength, but is the IRI algorithm that already include the process to take in consideration. What is important is that during the acquisition phase, to not apply high-pass filter that cut out some wavelength that can be useful for the profile and for the roughness evaluation. But usually in our RSP, we set 100 meters wavelength, so we don't have problem to miss some components useful for the IRI calculation. Michael say you have to drive a certain speed to collect roughness, but you can collect right after stop and go. Yes, Dynasty developed a system that is called stop and go. Of course, usually we say that we need to have a constant speed or a speed higher than 20 kilometers per hour. This is because otherwise the profile you collect can be affected by the long wavelength, or the accelerometer is not enough excitated. But thanks to our reverse filter, we can anyway collect the profile also at low speed, and this allow us to measure also in traffic condition. Praveen asks us, you need calibration right for profilometer? Yes, in our case, calibration is different for Mark III and Mark IV RSP. For the Mark IV, that is the portable, the calibration is itself calibration. So you need just to verify the calibration. Mark III has a calibration procedure that can be provided by the operator, so can be done regularly or before any collection, but the user can perform itself. And one say, IRI evaluation on gravel road, what are recommendation? Gravel road is you can perform. Of course, sometimes the accuracy of inertial profile can be much higher of what is requested from the gravel road. It depends on the status of the gravel road, but anyway, you can measure. The laser is properly working also on gravel surface. Carlos say, what is the best sample interval for IRI? 10 millimeter or 10 meter? I always use 100 meter, but some customer ask for 10 meters for cleaning some bumps and the average. Yes, you are right. 100 meter is a typical suggested one, but by the time people probably understood that some peaks inside 100 meter can be averaged with the rest of the sampling intervals. So sometimes now the road authority, they introduced a statistical evaluation of the data collected or elaborated at 10-meter interval. In this case, we can see also small irregularities. So maybe they request that more than 90% of the 10-meter interval IRI is below 1.8, and maybe they can accept that 2% is over 2.5 IRI, millimeter by meter. Of course, 100 meter smooth a lot the roughness evaluation. Using 10 meter, you can identify also if you have single bump. The criteria has to be decided by the work supervisor or the designer. Can we use the RSP to measure transversal irregularity? Yes, you can use the RSP, but you need the Mark III RSP in our case, and we suggest to have more than 7 or 11 lasers. So because more lasers you have and more accurate is the transversal profile you measure. So you can do that, but you need a consistent number of laser installed in the RSP bar. Carlos, you wrote 10 meter again, but I cannot understand your second question. I hope to have not missed any question. Yeah, okay, Carlos is fine. Yes, I understood that it was 10 meter and not 10 millimeter. Don't worry, it's fine. So for the RSP, we can install the equipment on any vehicle, or we must have a special vehicle? No, the RSP can be installed on any standard vehicle. Yes, we install it from small car to big van, but it depends which one has a different weight. So we need for the RSP Mark III, we need to fix a special piece, or for the Mark IV that is quite light, we can just use the towing hook vehicle in the rear if you want to install a rear part. But you don't need a special vehicle. Any one you have is valid. With 4 wheels is valid. Okay. If there are no other questions, we can close here. Thank you again to attend this webinar. We hope it has been interesting, and we are organizing other webinars. Maybe in 2 months we have another one. So we hope to see you again here and follow our webinars. Please don't miss to follow Dynatest on socials, just to be updated about any news. Thanks. Good evening. Have a good day. Bye.